Dear 2017 Computational Decision Making and Data Science Workshop participants, we wish you a very warm welcome at Belgrade, Serbia, on behalf of the organizers, the University of Belgrade, Faculty of Organizational Sciences, and the Macedonian Academy of Science and Arts. The two-day workshop consists of 4 invited talk sessions, with a total of 13 talks and 2 industrial talks. Computational decision-making is an emerging research field that aims to build new methods for efficient decision-making using advanced computational tools. Similarly, data science is becoming one of the most important research fields, covering the areas of machine learning, data mining, pattern recognition, visualization, data engineering, and other disciplines. In recent years, data science methods were successfully applied to a large range of areas, including health, biology, climate, marketing, and etc. This workshop aims to address challenges in the areas of computational decision-making and data science, and to facilitate interaction between academia, industry, and funding agencies. This year, the workshop will be organized around 4 topics. First one is data science and smart society. Second one, computational methods for public policies. Third, computational challenges in data science. And last, fourth one, data science in medicine. Now, I give the floor to Professor Sanja Marinković, the Vice Dean for International Cooperation of the Faculty of Organizational Sciences.
Thank you. Ladies and gentlemen, dear colleagues, dear guests, welcome to Belgrade. Welcome to Faculty of Organizational Sciences. I hope you will have time to visit the faculty, as it is very close to this building. Just let me say a few words about the faculty. We celebrated more than 45 years in teaching. We are in fields of management and information systems. I can proudly say that we are the best faculty for management in the country and one of the leading faculties in information systems and technologies in the country. We are very open to cooperation, and we have contracts and intensive cooperation with different universities and faculties in Europe and in the world. Also, we have more than 700 contracts with companies here in Belgrade, but also in Serbia. So our cooperation is in industry very intensive, and one of the projects that we completed last year, we opened the Center for Research and Development at the faculty with the goal to connect our students, their innovative ideas, and the companies seeking for young talents. So I hope you will have time to visit the faculty also. I congratulate Boris for organizing this conference, and he is very successful in getting together people from this field. So I wish you a pleasant stay, and I wish you very successful work in these 2 days. Thank you.
Thank you, Professor Marinković. Now I give the floor to our main industrial sponsor, Nebojša Bjelotomić, CEO of Saga Belgrade.
Very, very warm welcome from my side. I'm really proud that we managed to organize this again. It's now 3rd, so we can call it a traditional. Saga is 2nd year sponsoring this. And I think that this event really hits the all right notes. First of all, we organize it as a regional event, so thanks to Macedonian colleagues for being with us, and we definitely commit on having a equivalent in Macedonia at some point, hopefully this year, if not then certainly next year. The second thing is that I think the data science is giving us a great opportunities. You know better than me what everything that is possible from scientific side. But let me tell you that in terms of commerce and economy, it's being recognized of everything that we can achieve and do with all the data that is out there, and how we can improve the lives and in the process make money, which is, for our part always interesting. So the thing is that putting together this event, we try to foster thinking and implementation of various methodologies, techniques, and ideas to something that can cross very easily to economic side of the story. And we hope to develop this further. I'm really proud how the roster of presenters is developing, and I think we're improving year over year. So we'll try to expand this, include a little bit more. We're discussing for next year, maybe even having an offshoot with the startups in parallel and so on, because I strongly believe that academia is the hotbed of ideas, but then we have to make that wall between the academia and the market lower, so that these ideas flow freely and we commercialize them. So I have a bit different maybe angle looking at the things from you, but I think that we look at the same things and we believe in the same things. So I really wish you a warm welcome, and I'm really excited that we are going to talk about issues that we are talking about in the next 2 days. And I think they are very important. And I also thank Faculty of Organization Science, because I think the pattern is very clear, and if I look at the universities from where our speakers are coming, usually every city on the list, Stanford not to mention, but Edinburgh and Stockholm, you see a clear parallel in a very strong startup community. So we are hoping to maybe achieve the same thing, fostering the academic cooperation and then creating more ideas, and then from there encouraging students to cross into this other side of the market, and then build from there. So that's why we are here. That's why we support. It's straightforward, but I think it's also very important to look at that side. Maybe it's a bit tainted from academic point of view, but I think also very important. So again, thanks for coming. Thanks for being here. I wish you a successful 2 days. I hope you sharpen your ideas and you come with some new ideas from this event, because that's all about it. Thank you very much.
Thank you, Mr. Bielatomic. Now I give the floor to Professor Boris Delibasic to welcome you on behalf of the organizing committee.
Hello all. So thank you all for coming first to Belgrade. Thank you for the invited speakers. I know it's now season of holidays. It was very hard to get you. I know your time is precious. So we are very happy that we have you here. We are actually very proud. We come from an institution that Sanja says we actually, regarding all stats, the best faculty in Serbia. Maybe that's not something worldwide, but here we are very good. The best students, we have the best student intake each year. So many people are jealous of us, but okay, we are continuing to improve. So let me say also thank you to the audience that came and that supported this. Also from my colleagues from the faculty, because they have now an important meeting and they came here to support this conference. So thank you all. I hope you will have a good time. You are in a very good hotel. You have very good cuisine here, very good cooks. You have coffee breaks all day long, so you can have a coffee whenever you want. Just take care not to take too much. You have Wi-Fi here included. It's this Horizon Wi-Fi net, so you can log in. There is no password needed. And that's actually everything I have to say. The weather is pretty much hot for this part of year. Tomorrow maybe it will be some rain, I'm not sure, but some say it will be. So I just want to thank at the end our sponsors, really, the Office of Naval Research Global, that actually made it happen that all these remarkable speakers came here and stay in Belgrade. Saga for being the industrial sponsor for supporting us now the 2nd years in a row. Our Ministry of Education, Research and Technological Development that also supported this event. And of course, the organizers, you heard already about that. So, thank you all once again for coming. And now we will start the workshop, 2-day workshop. And now I give the word to Ljubčo Carev, professor from the Macedonian Academy of Science and Arts. Thank you.
Thank you. Thanks very much for the invitation, and it's very pleasant to be here in sunny and warm Belgrade after cold and grey Edinburgh. So my name is Michael Rovatsos. I'm with the School of Informatics at the University of Edinburgh. My research area originally is multi-agent systems and distributed AI. But as you see from the title, I've recently gotten much more into thinking about smart human societies rather than societies of computational agents, of course, using the modeling tools of AI and multi-agent systems in the process. So how do we make smart societies fair is kind of the title of this presentation. I don't have a solution, I will say this much from the outset, but I have some ideas and I'll present some work we've done on this in several projects. So what I'm going to talk about is broadly defined as what we could call collective intelligence. It's very much to do with the things that were talked about in the previous presentation, and I really appreciated this perspective on people actually doing things together rather than people being just the source of data and just contributing things, the signals that we can just pick up and analyze, which is a much more passive involvement of people. And this is not what's happening in the world nowadays, and this is not what's happening on the web. What's happening on the web is a kind of quiet revolution where now, for the first time, we really have massive scale systems that enable collaboration. And this comes in different guises, and it happens in different areas. So we have sharing economy, you know, Uber and Airbnb and all these kinds of platforms where essentially you have excess surplus supply of resources that could be allocated to meet some demand, like people's cars or people's houses. But you also have social media and you have kind of crowdsourcing platforms and all these things where essentially everything that happens is always a combination, what we call smartness is always a combination of human and machine intelligence. So until now, what has mostly happened is that people provide human intelligence, they provide the actual kind of insight, and machines mostly provide logistics and data analysis and some what used to be fairly mundane functionalities. But of course now this enables a different type of AI and a different type of intelligence that is also driven by machines. Now, why do we need these societies to be fair? Well, this collective intelligence can only really happen if people engage. And if people engage in sustainable ways, in responsible ways, in safe ways, and if these communities grow and they become self-sustaining. So one of the projects I've been involved in was called Smart Society, just finished, it was a big EU project, just finished last December. So its title was Hybrid and Diversity-Aware Collective Adaptive Systems, where people meet machines to build a smarter society. And the only reason I'm reading this out is that it really says what it is. So we were very much interested in how do you develop solid engineering principles and theoretical frameworks for these things that are already going on in practice, but they're still somewhat a black art. So, you know, when people start an app like that, you don't know whether it's going to work, you don't know what makes people engage, and you don't know whether it'll be successful or not. So we set out to understand these processes better, and this was a huge collaboration, and we brought together people from distributed systems, from AI, from human factors and HCI and so on. We did a lot of work on privacy and ethics that I'll talk a little bit about. And basically, the kinds of scenarios we were interested in, our vanilla flavor scenario was always ride sharing because it's something that everybody understands. you want to travel together, you want to share resources, you want to get a cheap ride, a comfortable ride. There are different people with different preferences. There is genuine collaboration, there is sharing of resources, and it's really just a placeholder for all kinds of other things. So the things that were mentioned before, like working, well, I don't know why this is advancing. It shouldn't, really. So what you really have is a very complex combinatorial problem. Imagine thousands, hundreds, thousands, millions of people with different profiles and different needs, and they need to be matched with each other, but you don't just need to recommend some movie to somebody who's going to watch something on Netflix. You actually need to create teams of people who are going to do things together. So this happens in lots of other domains. It happens in scheduling meetings, in traveling together, in building kind of software developer teams with freelancers. All kinds of applications have these similar properties. And the real issue here is, well, if we knew that everybody is the same in a hypothetical universe where everybody's just a robot with the same preferences, capabilities, and so on, then it just becomes a problem of optimization. It just becomes a problem of aggregating all this resource and finding an optimal allocation. But with humans, what happens is they're all very different. So we did an initial study, for example, with our colleagues in Israel. I'm very surprised to find out that the two main things students cared about when they were sharing cars to drive home at the weekend from university to their homes was whether somebody was smoking in the car or whether there were pets in the car, right? So especially dogs, because people, depending on cultural context, can be afraid quite a lot of dogs. So these were constraints that our app didn't even capture. We never thought of. So this is what happens when you go and you talk to real people. You find out they are not just algorithms. They are very different, and they have very things that you need to find out by working with them, really. So one thing we wanted to work towards, and that we actually made some progress towards, was to kind of get away from this idea that, well, it's just somebody pre-designs the kinds of tasks and activities that people can do together, and then builds an app that just performs the matching and performs the optimization. We really wanted to get to a point where the machines would actually learn from people. So we built this little demo that was still quite basic, but it basically was called Ask and Share, and it was a combination of people actually proposing new types of activities, and then other people being able to join them, and over time, the algorithms would extract what the common features are of these things and would learn what the context conditions are under which people actually collaborate with each other, and what needs. So it's also a way of kind of building, crowdsourcing kind of common sense knowledge about the world through a combination of human-based crowdsourcing and machine AI. So to give you an example, our vanilla flavor example was, you come to a city, you come to Belgrade, you have no idea about what's going on, so you use the power of the crowd, you say, oh, it's going to be incredibly hot tomorrow, what should I do? And then somebody says, well, why don't you go to the National Museum? That's quite an interesting place. And then you say, well, okay, are there people who would like to join me? And then maybe you find out that somebody says, oh, but it's Monday and the museum is closed, so you can't go. So over time, this could be actually even a way to develop an adaptive kind of travel guide where these recommendations could be replayed, for example, by an algorithm rather than by people. So it's kind of this, we really wanted to explore this hybrid machine-human collective setup where both sides learn from each other. So a lot of what we did went into a complex software platform, and I will not bore you with all the details, but I just want to highlight all the things that went into that. So there were a lot of things to do with activity and context recognition. So for example, when people are in the car, are they driving, have they left the car, and so on. So that's typical kind of pervasive computing context-aware computing type stuff. There's a lot of privacy stuff. So for example, we wanted to have very transparent and clear policies about what what all the different peers know about each other. So if I'm, if my daughter tells me that she's on the way home from school, then maybe I'm, as a parent, I'm allowed to observe her location, and that feeds into the system, but maybe her friends aren't, or other adults wouldn't be, and they just know that she's just somewhere in the city, and so on. So, and then we had a lot of monitoring of, a big emphasis on accountability and transparency, so we put a lot of work into recording the provenance of all the operations in the system and trying to analyze who made what changes to what data and which algorithms also made which decisions at what point to have this kind of accountability. And then also a lot about incentives, where we did a lot of experiments in citizen science, for example, where there were different things we could try to do to keep people engaged with the platform. So, for example, telling them science needs your help, please continue contributing to the platform, or trying. There were lots of users that were scared of misclassifying images on a citizen science platform, and we told them, don't worry, your whatever you submit will be cross-validated with lots of other contributions, so you cannot cause scientific failure alone. So there were lots of components that went into that, but I really only want to talk about what we did in Edinburgh, of course, which is this bit up here. Well, the red bit anyway, that's called social orchestration. So there we kind of tried to understand how we can better model the cycle of how we bring people together, create teams, get their feedback, and then in a cycle basically optimize this process. Okay, so you have to, up there you have discovery, you first have to find out the right people who could be involved in a task. Then composition, you have to create all the possible, compute the possible activities they could perform. And there are way too many of them, so you're not going to compute all of them. So you have to prioritize. Then you have to recommend some of them, some of these tasks to the people in the system. You don't know what they will like to do, what they will want to engage with. Then they have to negotiate with each other how they're going to do it. Okay, so it's not always depending on the kind of interaction protocol you apply. You may leave some freedom as to the details of, for example, when somebody should pick someone up for a ride and so on. And then finally they execute the task and you get feedback from people on the task, and that should ideally feed into what you're going to do in the future. So a lot of things that are going on there allow you to detect emergent patterns and to optimize your system. Okay, so what I want to focus on here and what I want to highlight as what becomes different when you work with people rather than with, let's say, an optimization system in a control setting, on a factory floor or in some other kind of industrial system, is how you should create the tasks that you want people to execute, and how you should do that. Mm-hmm.
So first is the feedback. Who gets that feedback? Is it a human being that is then incorporated the feedback, or is it an algorithm? And then you automatically incorporate that feedback.
Right. So the idea is that, both. So in our platform, as soon as something is being executed, anybody who is participating can submit feedback. And this can be feedback on any aspect of the task. It can be about each other, about that the constraints maybe of how it was supposed to be done were wrongly calculated and cannot be met, and price or time and so on. And of course, we analyze these algorithmically to, for example, match people again with people whom they liked. But also, it serves as an information source for people, which will, for example, feed into how they negotiate in the future with each other, or which recommendations they will like, because if I had a very bad experience with you as a driver, then I'm not very likely to do that to ride with you again, and so on. So again, it's this hybridity where you want to have both of these aspects. So I want to focus on this, what's called composition up there, so where you actually decide what kind of tasks to compute based on who you have on the system. Okay, so this is a complex combinatorial problem. Let's say you have a population of 100, even just 100 people, and let's say you have 20 drivers in there who could take up to 5 people, each up to 3 or 4 people into their vehicles and travel somewhere together. You can already imagine how many combinations that is, even after you've worked out all your hard constraints. So, you know, hard constraints would be things like origin and destination and the time frame within which they want to travel or they want to do. So really any constraints that have to be met. But then, of course, because you have such a huge number of combinations, you need to work out what are the soft constraints, right? So what are people going to prefer? You know, when you go on a flight search engine, we just had this conversation over breakfast, you never go down to the third or fourth page where a flight from Munich to Belgrade is $1,500. And there is a reason why then also these are dynamically generated from the databases, because the platform knows you won't go that far down, or if you do so, you will do so much later, so it can do this dynamically. So it's really all about working out what people want and what's likely to happen, but also actually, of course, influencing what's going to happen, right? So, you know, one trivial solution would be, well, all the drivers of the cars just travel alone, and everybody else just gets the bus or the train or walks, right? Or the taxi. Now, so there is a trade-off between trying to explore the whole search space to find the optimal solution at a system at a global level, but also satisfying everyone's individual preferences. Okay, and I think that's the whole game of this society design problem that was also mentioned in the previous talk. Now, traditionally, what in my area, in multi-agent systems, where people use a lot of game theoretic models, what people would do would be they would look at assuming you have some model of the preferences of everyone that can be somehow mapped to utilities, so you have some kind of numerical ranking of how much every solution is preferred by every agent. Then you would probably come up with some kind of global criteria that you want to satisfy, and then just compute an allocation. Okay, so there's a whole area called mechanism design, and for example, the splitted work mentioned earlier is based on this sort of work, where there is a lot of theory about how you can make these algorithms strategy proof, so that nobody has an incentive to lie, how you can make them efficient so that the social welfare, the sum of everyone's benefit, is maximized, and how you can address the complexity problems that happen in that process. Now, in those mechanisms, typically what you do is you tell everyone, you show all the participants a proof that these properties are satisfied, and therefore you can tell them, right, just tell me what your preferences are, and I will give you the best solution for yourself. Okay, now, unfortunately, this is not how the internet works. The reality is we don't know people's preferences. We cannot assume they're completely rational. And in practice, if we want to get anywhere, what we have to do is we have to give people some autonomy and give them some options to choose from, right? So imagine you went again on the flight search engine and just said, I want to go from Munich to Belgrade, and it just said, this is your flight, right? Costs $437, and that's you done, right? So this is not a system that you would be very likely to use if there are others that give you choice. And why is that? Well, it's because you don't know how the system has computed this allocation. You don't know whether you can trust it. You don't have you're not given a variety of options that you can compare, so you can see what else is out there. And so to address this diversity of people, where we can never capture everything that, so for example, when you have a strict game theoretic preference model that requires that you capture all relevant aspects of the domain, right? Now maybe I don't like to fly with no frills airlines because in between two flights I have to pick up my bag and check it in again, right, and go through security again. This is maybe not something that the search engine is actually asking me, right? So it can't tell my preference about it. And I think this is a more general problem, which is that I would claim no system will ever be able to capture everything that's relevant, right? So then what happens, this means that there will be uncertainty about the remaining things, and therefore you have to give people choice. So they can then, without actually modifying the whole system, they can then just pick and fill in the blanks, so to speak. So what is this problem really? The problem really is here to how do we compute these optimal sets of solutions, and then how do we influence users' choices if there is some global objective? And of course there are lots of ethical questions around that. Are we allowed to influence users' choice, and under what circumstances are we allowed to do that? And then of course we also have to learn the user's preferences. Now I'm not going to talk about part 3, we've done work on that, but it's kind of beyond the scope of this talk. But I'm going to tell you a little bit about what we try to do for item 1 and 2 in terms of algorithms. So the first thing you have to decide in these social systems is what do we mean when we say optimality? Okay, so here we had a fairly basic notion. So we have some model of the utility of the user, u sub I, and some global utility function, which we will assume depends on the sum of everyone's utilities. So that's called social welfare normally in mechanism design. And then also we have some indicator function xij, which is just 1 if any, so I are the agents and j are the tasks. So we want to maximize the number of people who are actually allocated something. Okay, because you could also have a solution where just 3 people do something and they're very happy and nobody else gets to go where they're going to go. Okay, so that's our utility function. And here comes just 1 out of 2 slides that contain some maths, but you can just not look at the maths and just listen to what I'm saying, and maybe that's a little bit more intuitive. So what we try to do here are essentially 3 things. So the first thing is we want to know, based on our utility measure, and this is all done with a mixed integer linear programming type optimization over lots of linear constraints. And so the first thing we do is we compute what would be best for the entire system. Not taking so taking everyone's utility into account, but not trying to balance the benefit between every agent and how happy they are. And also not generating further options. Okay, then in the second step, we find alternative solutions, these with this objective function, that are similar to this optimal solution, but they minimize the difference between how well off every individual agent is. Okay, so this takes equity into account. We don't want, the whole solution to be just optimal but some people being very well off and others being very poorly off. Okay, and then in the third step, and of course that may not be optimal. Okay, so we can only do that subject to some kind of percentage of maybe 70%. Let's say you set some threshold, you know the optimal value from the first step, and then you say, well, I want it to be at least 70% optimal. And then we want to give the agents choice, so we also generate a few other solutions that are generated by similarity to this solution. So we want them to be as similar to that one as the others, as the first one we've generated, but different. Okay, so this is the part of trying to address a little bit the diversity between the users, but making sure we give all of them an equally good outcome. So this already addresses equity a little bit. And now we also want to influence users, as I said. This is the more tricky bit. So how do we do this? Well, you could somehow intervene and tell them, oh, please, on our platform, female drivers aren't getting as many passengers as male drivers. We want to change that. Please join female drivers. Or you can give them some possible future rewards for behaving in a certain way. Or you can do it more implicitly, which is what we chose to do. And in particular, because in the ride-sharing domain, we can't really give them discounts because we have no money to spend. They only pay each other. So we introduced instead a system of taxation. And basically, what the taxation does is that the first solution we calculated, which the system thinks is the best, is what's called the sponsored solution. So this is very similar to things that people that are done in online in ad auctions and so on. So that's what we would like people to do. But then we generate, now for all the other solutions, we add a tax, and I can tell you about the math if I had more time. So basically you create a minimal disincentive for the other options not to be taken by the users. Okay, now this is kind of a fine line between compulsion and giving flexibility, so they can still take all these options, right? But we punish them slightly, and there are specific methods you have to use to not introduce taxes that are excessively high, so we really only generate the minimal tax that's necessary for them not to do what's good for the system. Okay, so we make artificially things that they might like, we make them artificially more expensive. And we can discuss the ethical implications of that later. So, if the agents are rational, they should then take our preferred option, and that should optimize coordination in the system. So what you really see in this context, well, with the experiments that we did, is that this kind of approach allows you to balance equity and system performance. Okay, so what we've really added here is to try to make sure that everybody in the system is equally well off while also maximizing system utility. Okay, and these graphs just show how that works, how this fine-tuning works. So the yellow bars are the comparative method. So this is where we just optimize system utility. And on the left, you can see the system utility, so the global efficiency. On the right, you can see inequality. So the higher, the more unequal the system is, the larger the variation between how well off every individual participant is. Okay, so for the yellow method, that's always the same. And then what we varied is we varied the limit of, remember when I said when you calculate an egalitarian solution, you want it to be at least as good as some percentage of the optimum. Okay, and then what happens is that basically the higher you set that limit, the more system utility you get and more inequality. Okay, so that's really the trade-off. And then dark blue and light blue is really just the difference also to show between then, because this depends very much on the assumptions you make about the behavior of the users. So the dark blue line, bars, are users who pick the cheapest option with 60% probability. So they're kind of, there is some probability that they might choose the others. And the lighter blue one are agents who pick the cheapest option with 80% probability. So these are kind of more rational, more focused on getting the best deal. And as you can see, when they are more rational, they behave more closely in accordance with what we would like them to do. But again, then when that happens, they, but interestingly, that does actually slightly reduce the inequality between them, because we've taken that inequality into account when we calculated what we wanted them to do. Okay, so this is just an illustration. It's not a solution, and it really depends on what types of user populations you have, what types of supply and demand patterns you have in every instance, because we've ran this, of course, over many, many rounds, and these are just averages. So it's just to say that when you have these issues, you have to balance lots of different criteria, and if you want to, and I've only really just explained how we balance two simple things, so global utility versus equity among the individual agents. There are many, many more, and in fact I have many, many slides I could show, which I'm going to have to skip. But the final thing I want to talk about is, so in the project we came up with this thing we called the Smart Society Social Charter, which was really based not just on the way we developed these algorithms. It was also based a lot on other work, field work that was done, where we found out what ethical problems and sustainability problems occur in the existing platforms. For example, there have been lots of protests surrounding Uber drivers and how they're exploited and whether they're remunerated appropriately. And then you've heard everything about fake news and echo chambers and trolling of websites and so on. So there are many, many issues where you actually have a scenario where there is shared responsibility between the platform and its users. And a lot of the social aspects of the global behavior of the system really depends also on the behavior of the users. And so we came up with this, oops, again it's jumping. So really we came up with these 3 pillars. So we said that, in order to have equitable, flourishing, and sustainable smart platforms, you need kind of respect for human agency. So we did that in our system by giving actually people choices rather than imposing something on them. You need to support diverse interests, so you need to have kind of the right models and frameworks that allow you actually to account for a broad range of possible users and stakeholders. And you need to manage value equitably, right? So if there are different stakeholders, you can't just say, well, all the profit goes to the platform and essentially all the users get nothing. And these horizontal lines then are the kind of the building blocks of that. So the topics, themes you need to address within those pillars. So you need to support community. This is something that many platforms don't have, so they actually explicitly don't want people to talk to each other, and they have to do that through kind of back channels. But actually, if you let people talk to each other, the platform learns much more about what they would like the social mechanisms of the platform to be. You need accountability and transparency. So I think this is actually the biggest problem right now. For most commercial platforms, we don't actually know how their algorithms work. And it's important for them not to tell us the details of how they work. And then you need privacy and safety. Now, safety so privacy is something that can be achieved, although again there are trade-offs. Of course you need data. You want to provide good service, you need good data. And then how you deal with the privacy is a big issue, and you've certainly heard that being discussed in lots of other contexts. But safety is a somewhat more difficult thing, because that also depends on the social behavior of the users, right? So if we're talking about how safe is it for somebody to, for a teenager to jump in the car with a stranger at night whom they've never met before, then there are issues there that can't be just resolved by the platforms. We can certainly think about technological ways of enhancing that type of safety when people interact with each other, but that's not just a technical thing. So that's kind of the, you can find this online and you can read this charter. It's a bit of a manifesto. We are sure that companies will never subscribe to this the way we wrote it, but it's a bit of a provocation, and that makes it potentially interesting. Unfortunately, I'm running out of time, so I won't talk about my other project, but I just want to show you my final slide. Which I think highlights, in this whole space of computational social systems, I think there are kind of huge promises and huge dangers. Okay, so I've already mentioned we were driven very much by this vision of people and machines collaborating and how that can really address big social challenges. You can solve problems in healthcare, climate change, poverty, you name it. I mean, never before were we able to leverage the knowledge of everyone on the planet at the same time. So that's really a huge opportunity that I don't want to talk down. And you can also massively improve personalization and the user experience that everyone has. But on the other hand, of course, people's behavior adapts to any socio-technical system. So at some level, you will always manipulate collective behavior. The question is, what are the governance mechanisms that ensure that we do that in ways that we want and that are transparent and clearly articulated? And and then there are problems related to that. Will the machines just use the people as human labor? Will we end up in a situation of constant surveillance of all our activities and so on? And so I think it's a very interesting space, and I think that's the end of my presentation. Basically, I just to give you a bit of insight into what we've done. And thanks very much for your attention, and happy to take any questions. Yes, so we have a toolkit actually where we try to package some of these components into something that can be reused, which is called Smart Collectives, which you can find online. And
how many people are using it? What is the sample size of your experiments?
So these, let me think. So these experiments that I showed you were simulation experiments. So we had, I think, even with our algorithms, we were limited still to kind of hundreds of people after you filtered out who could collaborate with whom based on hard constraints. Okay, so the total population could be much larger, but then you're really only interested in those people who are relevant to each other.
So have you tried the platform?
We actually deployed it, but unfortunately that was at the end of the project, and we didn't have the advertisement machinery to get a lot of users. So that was kind of what the project did.
You mentioned that people can talk to each other. So what kind of communication? Is it free flow communication, structured, or?
You can just basically chat to each other. But, okay, I have to make a distinction. So although you could do that, we did not apply any pattern recognition and data analysis on those kinds of conversations. That was really just a community thing for people to exchange views and so on. More questions? Right. Right. So I think, I think the first step is actually articulating and specifying what the values are that a platform supports. Okay. So for example, you know, Airbnb last year sent me an email saying, because I think there were some issues related to diversity and exclusion, and they said, you know, they really wanted to enhance how it's open to, you know, it's indifferent to race and age and gender and so on. But that was really an email. I don't know, for example, whether their algorithms do that. Okay, so I think what we need much more is we really need kind of metrics on the algorithms where, you know, you can say there is a, you know, there are a set of criteria, and as a provider, we subscribe, for example, to this metric that, you know, there are different fairness criteria now. People are working a lot on machine learning-based ones, where, for example, the outcome of the algorithm should be the same regardless of whether you're a man or a woman, or regardless of whether you're black or white. And, you know, so that could become a normative specification of a criterion that, you know, a provider could then say, well, we comply with that, or we can't comply with that for reasons A, B, and C. So there is actually, I'm involved in a working group, an IEEE working group on algorithmic fairness, where we're actually trying to come up with a standard for these things. But it's also very difficult because, so I can show you, actually I had some slides, for example, with some criteria that they use in machine learning. So I just mentioned, the one I just mentioned was unawareness. So, you know, sensitive attributes are not explicitly used in the decision-making process. It turns out that's already been discarded by researchers because actually it can generate more unfairness if you apply it. And then there are lots of others. For example, similar individuals should get similar outcomes. Again, I think that's already been contested and as unrealistic or incompatible with other things that you may want. So this is really a moving space, and I'm only showing you, I've got 7 here, but in the literature, this has only started a couple of years ago, and in the literature there's already lots more, and they're constantly one is being overruled by the other. So I really think we're only at the very beginning of this kind of debate. And we need to work out what the standards are going to be and what we actually want the providers to do. My real worry is, though, that, well, if you have 500 million users, you don't really need to follow these kinds of recommendations that some standardization body will come up with or some government. We have another project which I didn't get to talk about, where we talk a lot to young people, young internet users, about their perception of fairness on social platforms. And one of the most disappointing things there has been that they basically unanimously say, yes, the power of all that lies with companies, and no, government cannot do anything about that. Right. So then the problem what you have, thank you for this question because it allows me to stuff that I didn't have time to talk about. Let me just show you something that we did. Okay, so here is the outcome of here's an experiment we did with students in my class. So we said, okay, at the start of the semester you have to pick a topic for your essay. Okay, here's a list of topics. You can give us preferences, which one you like most, from 1 to 7 or something like that. And then, actually 7 was max and 1 was min. And then we said we're going to use 5 different algorithms to choose what each of you has to do. And you're going to tell us which one you like. Okay, we're not going to tell you how they work. But we're going to show you the distribution of what utility each of you achieved according to each algorithm, and how big the inequality was between all of you in the class. Okay, so here you see the utility distribution. So the points, it uses points because it's kind of the number of students, but the horizontal lines allow you to see how many students achieve a utility of 4, how many 5, how many 6, and so on. And the red points are the averages. And on the right-hand side, you see the inequality. So the inequality is the pairwise total distance between every 2 students, how happy they are. Okay, so for example, algorithm 3, extremely efficient overall, manages to allocate almost everybody at the very top, and actually quite low on inequality. Okay, so yeah. So we asked them which ones do you like most. And the interesting thing is that, so this is, top is which one do you like most, bottom is which one you like least, and then we told them how the algorithms work. Okay, so algorithm 1 minimizes total distance between everyone and guarantees at least 70% of the maximum total utility, which is kind of the method I showed you before in the talk. Algorithm 2 maximizes the utility of the student who is most badly off. Okay, so it's really trying to lift up those that get a really low score and still guarantees 70% of maximum utility. And then 3 just maximizes total utility, 4 maximizes just the minimum student utility, and 5 is just egalitarian. And then after we showed them that, we actually got a different outcome of what they like more and what they would like less. So yes, I would like to crowdsource this, but it depends very much on what you tell them and what kinds of metrics they get. So for example, I was quite shocked that they said, so algorithm 5 here is like, that's completely egalitarian. And they said, no, we don't want that, that's communism. Like everyone has to be poor just for everybody to be the same. Right? So, you know, it's, I think crowdsourcing also has its problems in that you go into these things with your ideas about, well, what would be sensible criteria, but then what if people told you, for example, no, we just go with the maximum social welfare, which is the one in the middle, which, by the way, is only that egalitarian because we had, I think, only 40 students, but 50 topics they could choose from. And luckily, they had quite different preferences, so they didn't conflict at all. Now, give them a different scenario where everybody wants the same topic, and that would be, you know, like some guys would get very lucky and some others would get very unlucky. So I think we should crowdsource them, but it also depends on how you do that.
Okay then, thanks again.
Thank you.